Hi, Yasmin Shabir here, working with the Better Lesson Master Teacher Project, teaching 7th grade math. In this reflection on interquartile ranges and variation, I'd like to share a small piece from this book, John Saffier's The Skillful Teacher. It's essentially a dictionary of teacher moves in the classroom, ranging from planning to instruction. And something that he has in his instruction chapter is on risk-taking and confidence in the classroom. It's something that I struggle with on a yearly basis. How do I infuse my classroom with a risk-taking culture? How do I get students to see that making mistakes in math is how we learn? He writes in this chapter that many authors acknowledge the importance of building this kind of culture, but very few offer strategies. So one of the strategies he shares from another author's writings includes a story where a physics teacher is instructing about gravity and asks this big question: does a 1 kilogram versus a 5 kilogram object fall faster? Does an object fall faster because it's heavier? And this was previously a quiz question many students got wrong. So the instructor was giving an experience here to students where they were exploring this concept. I applied this sort of strategy to this section of class where students had not done really well with identifying the interquartile range, and the reason why they were miscalculating it was because they were misidentifying the markers for lower and upper quartiles. The reason behind that, I found through many of my exit tickets, was that given an odd or even number of data values, students were either selecting the wrong number as lower versus upper quartile, or they were calculating it between two values when it wasn't necessary to do so. So I provided this worksheet for them, and I gave them 5 minutes to work on it independently, 3 minutes to discuss with neighbors their answers, and while they were doing this in those 8 minutes, I was throwing up answers on the board. He explains, John Saffier that is, in this story that the physics teacher did the same thing. He put up some of the common answers given in class, both right and wrong, without indicating which were right and wrong. And then he says in class, pointing out the wrong answers, "You guys probably felt pretty dumb after these kinds of answers. Don't feel dumb. Let's see what's valuable about each of them, because each one is valuable." I delivered the same message in class once I wrote down the common misconceptions. I showed students that they weren't the only ones. Look at how many people, every time I wrote it, someone gave this answer. If so many of us are having this wrong answer in our head, we have to talk about why. Why? So that we can all learn and get better at it. If we stay there and isolate ourselves and think we're the only ones, no one is learning. And very seldom is there only one person who thinks one answer is it. And if that's the case, I go up to them individually. So I encourage my students to share things out, especially when I say, "What answer did you get?" Many times that's because I'm seeing that wrong answer multiple times. And I share it this way with students to encourage that risk-taking culture. I encourage them by letting them know you're not alone. So that's one strategy I've been pulling out of this book. It's definitely something I'd recommend you add to your bookshelves. It's a great strategy and resource here. Just to point out very quickly, this is the worksheet, and the most common locations for the wrong answers were included here in the lower and upper quartiles needed to calculate the interquartile range. So up on the board, I would project this worksheet, and I would write down some of the answers like this that students were giving for each of these so that they could see that they weren't the only ones making those errors. Hope that's useful. Thank you.